So here what we see, a partial equilibrium model. The partial equilibrium, so basically this system we have three equations in here. The first equation tells you that the quantity demand is given by A minus B, P, where A and B are the constants and this capital P denotes the price, the market price. So you see that from the first equation you can see that the quantity demand is it's proportional to the price. If the price changes, then the demand will also change. Suppose you see the basic price law is that whenever price increases, the demand decreases. That is what we have, the basic law or price law. Now the second equation, this tells you the supply, quantity supplied, that is equal to minus C plus dP, where C and D are constants, same as before, like A and B, and capital P denotes the market price. So again you see the supply is depend upon the price. Now the next thing is the equilibrium status is only achieved when the quantity demand is equal to the quantity supplied. So it means what, there is no waste in any quantities. So whatever you are supplying is the amount that has been demanded. So this is my third equation. Now with the help of these three equations or this market model, we have to find the value of the equilibrium quantity supply, equilibrium quantity demand, and equilibrium market price. So for this problem, what we need to start with is we need to rewrite these three equations in this way. So what I'm going to write is it will be like this: QD plus BP is equal to A. So this is basically the equation number 1 only. So how we are writing this thing? So basically what we are doing in there, you see the equal to sign. In the right hand side of equal to sign we have the constant, and in the left hand side we have the variables. You see the variables are what? QD is a variable, then P is a variable, then QS is a variable. So we have three variables in this question. So what is my main purpose? In order to write the equations, we will have the constant in the right hand side and the variables in the left hand side. So the second equation becomes QS minus dP is equal to minus C. This is my second equation. Now the third equation would have been, so it's quite obvious, you have to take QS this side, so it is QD minus QS is equal to 0. This is my third equation. So these are the three equations which we have. From these three equations, with the help of these three equations, we need to find QD, QS and P. Now you see, in all these three equations, the three variables are not present. If you look at the three equations, all the three variables are not present. So how are we going to write this one as? We can write this one as QD plus 0 into QS. Since QS is not present, we will have 0 multiplied with QS, because 0 into QS means what? It's completely 0. So it means there is no existence of QS. But why we are writing this thing? To have a proper representation in matrix form. Then plus BP is equal to A. This is my first equation which we have written in this form. Now the second equation is, you see the first letter is what? The first variable is what? QD. The second is what? QS, and the third is P. So in this way, in the second equation, you see QS is my second. So what I'm going to write here, I'm going to write here 0 into QD plus QS, then minus DP is equal to minus C. This is what we have, our second equation. Now the third equation, it is QD minus QS, and there is no P. So I'm going to write here plus 0 into P is equal to 0. So this is how we're gonna write those three equations in this form. So this was basically my first equation, it was my second equation, and this is my third equation. Now in matrix form, I already told you guys how we're gonna write this thing in matrix form. So let us do it. So we will have three matrices. One is the coefficient matrix, that is A. So let us have that A. So let A be the coefficient matrix. Okay, no, let us do all this thing. Let A X and B be the coefficient matrix, then X is what? The variable matrix, and the variables we know. What are the variables in here? Variable matrix, and P is this QA, this side is my, these are my constant matrix and constant matrix respectively. So this is what we have. So let us write this, let us find A, B, X and B. So A is given by what? A is given by, look at here, the coefficients. So I need to have all the coefficients. So here you have QD. So QD alone means what? 1 is the coefficient of QD. For QS, the coefficient is what? 0. For P, the coefficient is what? B. For QD, for the second equation, you see the coefficient of QD is what? 0. So here I have 0 in here. The next one, QS, nothing is there. If nothing is there means what? 1 is multiplied with it. So the coefficient is 1. And for this one, you have what is multiplied with P? It is minus D. So it will be minus D. For the last line, it is QD alone. So it means 1 is multiplied. QS alone, QS is multiplied with minus 1 and P is multiplied with 0. So this is the coefficient matrix which we got. Now the next thing what we are going to do is we're going to write the variable matrix. So the variable matrix is given by, so what are the variables? The first variable is QD, the second one is QS, and the next one is P. So these are the first variables which we got. Okay, one thing you see, since we are directly, by solving these problems, we are directly finding the value of QD, QS and P. Now those values, they are particular values, right? So those values gives you the equilibrium value, because maybe in a system there are fluctuations. The price of a certain quantity may increase or decrease at certain point of time, but there is always equilibrium state to it when t tends to infinity. I think you have learned this one in application of differential equation, first order differential equation. So when t tends to infinity, then pt, that is time path, pt tends towards p equilibrium. So all the values of the market price at any particular time, they always converge to the equilibrium price when the time tends to infinity. So here, since we are trying to find the value of these QD, QS and P, now these values will always be the equilibrium value. They will always give you the equilibrium value. So this is my X and my B is given by A minus C and 0. So this is what we have, A, X and B. So now what we're going to do is, so in matrix form, how are you going to express these equations? We're going to express them as AX is equal to B. So A, we know A is what? 1, 0, B, 0, 1 minus D, 1 minus 1, 0. Then, sorry, we have to write X in here. So it will be QD bar, QS bar and P bar is equal to A minus C, 0. So in matrix form we got this thing. So we need to find the value of QD, QS and P. So basically this QD, QS and P, they are nothing but which matrix? They are this matrix X, that is the variable matrix. So all we need to do is we need to find X. So this A is a problem. So we need to take this A that side, and how in matrix we cannot do divide. So what we do? We do inverse. So here we're going to write by matrix method, we're going to write this one as X is equal to A inverse B. So basically we have to find the A inverse. So QD bar, QS bar, P bar is equal to 1, 0, B, 0, 1 minus D, 1 minus 1, 0. And this one is A inverse of this, and B is your A minus C, 0. This is what we have. This is what we have. Now either you can find the inverse of this thing by finding the adjoint or determinant, or you can solve this one by Cramer's rule. It's all up to you, but I suggest you to do by Cramer's rule, because Cramer's rule is far easier this one. So let's try Cramer's rule. So for Cramer's rule, what we have is first we need to find determinant of A. Even for A inverse also you need to find determinant of A. So determinant of A is given by what? 1 0 B 0 1 minus D 1 minus 1 0. So this one, if I have to expand this one, so I will expand along R1. I am expanding along R1. So what do we get? So if I expand along R1, so the first element is 1. So 1 into, now you cut this one and this one. What element remain? 1 minus D minus 1 0. So you have 1 minus D minus 1 0. This is my first. Now the second element is already 0. The second element was minus. So if it is 0, we don't need to write anything anymore. Then the next one, first one was plus. This element was plus. Now this element was minus. The next element will be plus. Plus, it is what? B. B. And what are the elements that will come? This one goes. It's 0 1 1 minus 1. 0 1 1 minus 1. So if I expand this one, you get minus D, and this one is coming out to be minus B. If you look at carefully, it's coming minus D and minus B. How is it? Look at here. If I cross multiply, this thing is 0, and minus of minus D into minus 1, that is what? Minus of plus D. So you have minus D, and this thing B into, this is again 0, and minus of 1 into 1, this is the thing which we got. So that is equal to minus B plus D. So this is my determinant of A. Now the next thing we need to find is, wait a second, it will be A, Q. Okay, no, we can directly find the values. We don't have to write this thing. So QD bar, we need to find QD bar. So for QD bar, what we are going to do is, we're going to write the determinant. Now QD is basically what? It is the first element. So I will replace all the elements of the first column. I mean to say, I will replace all these elements. Since I am finding QD, I will replace all these elements of A by what? By the constants. So replace all these elements by constants. A minus C0. So the first one, it will be A minus C0, and the next one what we have is 0 1 minus 1, 0 1 minus 1, and the last one is B minus D0, B minus D0, B minus D0. And we have already found determinant of A, and so we're going to write here B plus D, and there is a minus sign in here. So now we have to find a determinant of the numerator. Here you don't have to write the expansion, you directly write. So what we have, I'm expanding along row 1. So if I do A, it becomes what? 1 minus D minus 1 0. Then you have plus, sorry, I'm going to write this thing, minus 0 plus B, you get minus C1 0 minus 1. This is what we get. So if I expand this one, what we have is minus AD, and this side you have plus BC. You have minus AD plus BC. Okay, this is what we have. Yep, and divided by minus of B plus D, So what we're going to do is, this minus sign I will take it up, and we can write it like this: B plus D minus of minus AD plus BC. We can have this thing. Now if you multiply that minus sign inside, it gets AD minus BC divided by B plus D. So this is my QD. So likewise, we have to find QS. So QS will be equal to what? QS will be equal to the determinant value of, now here the second row means this one will be replaced by the constants A minus C0. So let us do that. So we have here 1 0 1, A minus C0, A minus C0, and the last one is what? B minus D0. B minus D0. So determinant of A, we already know the value of determinant of A, that is nothing but minus of B plus D. So now QS becomes how much? Now this one will expand along column 1, because row 1, you see there are 3 elements are there. So let us expand along column 1, because or else we can do by what? Row 3, because there is only 1 element is there, other 2 are 0. It will be far easier. So let us expand along row 3. So if I expand along row 3, the first element is what? 1. 1 is there. The 1 multiplied with what do you get? Cut this one and this one. You get A, B minus C minus D. A, B minus C minus D. And that's done, because the remaining elements are 0. I don't have to write anything. So let us expand this one. It becomes minus AD, and you have plus BC divided by minus of B plus D, and that is equal to, again you put the minus sign up, so you get minus AD plus BC, so you get AD minus BC divided by B plus D. So you see, this is nothing but equal to QD. So when in the equilibrium position, the quantity demand will always be equal to the quantity supplied, because there is an equilibrium, there is a stable position. That's the stable position. So QS and QD done. Now we have to do the last one, that is P, equilibrium price. And for that equilibrium price, we're going to do is what? Determinant of A. And now the last set will be replaced here. Wait a second, let me just write these 0, 0, 1 minus 1, and in place of this third row, in place of this third column, I will write the constants now. So A minus C 0. Now the last one will be A minus C 0. So this is what we have. So determinant of A value is already known, that is minus of B plus D, and the numerator becomes, the numerator becomes, we'll expand along row 1. Now what do we have? 1 into, you get 1 minus C minus 1 0. How do you got this thing? Just cut this one, you get 1 minus C minus 1 0. Now the next one will be minus sign, but it's 0, I don't need to write, plus A, and A will be multiplied with what? It will be this one goes 0 1 1 minus 1, 0 1 1 minus 1. This is what we get. So let's do it first. So we have minus of B plus D, and here we get minus C. If you expand this one, it's coming minus C, and this one it's coming out to be minus C. It's coming minus A. So basically what we are getting is, from the numerator we can take minus common. We can write this one as A plus C, and from the denominator already a minus in there. So this minus gets cancelled, and we have A plus C, B plus D. So if you recall from the first chapter of differential equation, the application of differential equation, so you will see the equilibrium price was A plus C divided by B plus D. So that's how we solve this problem. Okay.